So let's start loading an image of a true color for a region. For that, let's define a region. Let's draw a rectangle like this. So this is the extent that we want. So let's define this geometry as a region, and for this region we want to generate a true color image. So first of all, let's define a variable called data, and let's import our data. So we need Sentinel data. So let's search Sentinel. We will be working on Sentinel-2 multispectral instrument data. Let's select it. This is the collection snippet. Copy it, and you can also directly import it from here. So let's import it. So there are two ways to import your data. The first one is in the import section. You can import it directly, or you can import it by using a variable data and copying the Earth Engine snippet here. Both the methods are correct, but I'll start with my own dataset. So I'll just delete it from import section and I'll import my data here. Then I'll filter it. So I'll define a variable filter and I'll import my data. Then apply a function filter date, and I'll filter it for the year, let's say 2020 01 01. So always keep in mind you can filter the data based upon your data only. So for example, let's go to the Sentinel data. Under the Sentinel-2 multispectral instrument, we are looking for surface reflectance. This is the dataset availability from 2017 to 2021. So we can filter the data for 2020, 12, 31, that is the 1 year data. So I'll just terminate the statement and move ahead. Now our data is filtered. So let's clip our data. We'll define a variable clip and pass on our filtered data. Mean it, because this is the data for one whole year. We'll average it and then clip it for our region. That's it. We have clipped the data, the filtered data. Now we'll define the visualization parameters. So here you have to pass on the minimum and maximum reflectance values. So for a Sentinel image, the reflectance values are 0 and the maximum value is 3000. Now you have to define the bands which you are using for. So don't worry about the bands. We'll see what all bands are there. So for Sentinel-2 data, go to the band section, and here you can see the name of the band, that is B1, B2, B3, B4. Then the scale. 1 pixel represents 60 into 60 meter. Then the wavelength corresponding to band 1, and the description. Why is the band used? So band 1 is corresponding to aerosols, band 2 is the blue band, band 3 is the green band, band 4 is the red band. So for a true color image, we would be requiring a red band, a green band, and a blue band. These three bands would be required to generate a true color image. So we'll be using B4, B3 and B2. So let's jump back to the code editor and pass on B4, B3 and B2. That's it. We have successfully defined the visualization parameters. Now set the map center. Let's say 78,28 and zoom level to be 10. This is one way of centering the map, but since you have already defined a region, you can set your map center around your region. Just comment your line and move ahead. Map dot center object, and here you can pass on your region. Now just add whatever you have filtered and whatever you have clipped. Map dot add layer, your clipped image and your visualization parameters. Let's say name the image as a true color image. That's it. Terminate the line and just run it. So I'll just toggle it off, move it. So here you can see a true color image of your region. First of all, we have imported the data, then we have filtered the data, then we have clipped the data for our region, then we have applied the visualization parameters, then we have set the center around our region, and finally we have added the layers to the map. That's it. That's how we generate a true color image of a region. That's it. See you next time.